Hey guys, welcome to another video. So today, another video in the final questions series of videos that we're doing. Today's question comes from the Extension 1 syllabus from the Sydney Grammar 2023 trial paper. The final question in the Sydney Grammar test usually is quite hard. Today's question is in the topic of polynomials. So before we dive right in, as always, if you're liking these videos, subscribe to the channel if you haven't done so, tell your friends, and then like the video after you watch it, guys. Let's dive right in. So, Sydney Grammar 2023. All right, let's have a read. So, monic polynomial degree 4, okay, that's information, has zeros, so roots of m and n. Okay, two zeros. Okay, powerful, must be double roots. Yep, okay, multiplicity 2, perfect. Write down the equation. Okay, it's not too bad, just two perfect squares, right? Two double roots. All right, that's 1 mark. The curve, okay, that negative sort of quartic graph, okay, so I'm just going to highlight that. And the curve, okay, there's two curves are shown. They touch each other twice. Well, that's important, right? Twice, right? So they cut each other twice there and there, okay. Using the result from 1, find the values of A and B. Okay. Feels like I'm going to solve simultaneously of some sort, right? All right, let's do this. So the blue is fact, the green is the question, and pink is any sort of special information for those that are wondering about the color code. Part 1, guys, if a polynomial has degree 4, quite simply, m is a double root, n is a double root, and we move on. Nothing to see there. Pretty straightforward double root there. Okay, what are we seeing here? So technically, to find those points, right, we solve them simultaneously, right? We set them equal to each other. Now, when I do this, right, so if I set fx equal to gx, right, I sort of have like negative x4 plus x3 plus 4x squared minus 4x, right, equals to ax minus 2 squared plus b. Okay. Now, if I move everything over, right, I sort of get like a polynomial, para 4, with a and b unknown, right? So I'm going to go, I'm going to move it over to where para 4 is positive, so maybe move that over this side, and I'll expand everything, right? And then I'll collect, so collect all my like terms just to make it nice. So this is like what's it, x squared minus 4x. Be really careful with my algebra, or try to be. Yeah, so that's like ax squared minus 4ax plus, and what looks like to be 4a plus b. All right, guys, so let's move a ring over. So therefore I have, so if I gx minus fx basically, right? Yeah, equals to x4 minus x3. Now, these guys combine, so plus a minus 4x squared, and then plus bracket. Now this guy's negative, the x is positive, so I'm going to go 4 minus 4ax, and plus 4a plus b. Guys, I'm going to quick pause that, check my algebra. Looks good. Now, this is the game plan, right? So if this guy here becomes a polynomial, and I'm expecting 2 roots, right? Using part 1, this quartic, right? I'm going to let that equal to x minus m squared, x minus n squared, right? And then what I'm going to do, I'm going to expand the right and maybe compare coefficients, or I can use sum of difference. Oh, sorry, like relation of roots, right? Sum of roots, product of roots, etc. To say compare. Either way is fine. I think the easiest way might be just to expand everything, right? So I'm just going to expand everything here. So 2mn, well, also mn, m squared. No, 2xm, or let's go to mx plus m squared. X, well, that's a square then. X squared minus 2nx plus n squared. So expand that, x4. So I'm just going to x squared times all these first. So 2nx cubed plus n squared x squared. And the middle guy times all of it. So minus 2mx3. Just tedious algebra at 4mnx squared minus 2mn squared x. Wait, that times the last one, yep. Okay. And then plus m squared x squared minus 2m squared nx plus m squared n squared. Okay. All right. Let's see. So collect your like terms. Now, which ones are cubes? That guy's a cube. That guy's a cube. I think that's it. So let's go minus 2n minus 2m x cubed. See, that's a squared. That's a squared. That's a squared. Okay, there's 3 of those. So be n squared. Oh, let's do it in order. M squared plus 4mn plus n squared plus. Now the x's, there's this one and this one. So minus 2mn squared minus 2m squared n x and then plus. Cool. Compare coefficients, right? It's probably the easiest way. Now let me see. I don't know whether I have space. Maybe. Okay. So it looks like I'm going to get 4. Like obviously, guys, using my colors, right? This guy compared to this guy, nothing to see there, right? Don't even need that one, right? Now there's a negative there, -1 compared to, whoops, compared to this, right? So -1 equals to minus 2n. Yeah, let's rearrange the order. Right, that's number 1. And if you sort of rearrange it, it'll be m plus n equals to 1/2. Okay, cool. That's the pink one. Let's use different colors. This is the same as this. So set that equal to each other. And you get m squared plus 4mn plus n squared equals to a minus 4. Okay, I don't think, also, not arrow equals to, right? Yep, I don't think I can simplify that anymore. So next color, orange, that, and that. Okay, that gives me my x1, so it's like minus 2m n squared minus 2m squared n equals to 4 minus 4a. Maybe divide everything by -2. Now I can even factorize it, right? So let's see. I can even factorize. So divide everything by 2, okay. And then maybe factorize a bit that times that. Divide by -2 will be 2a minus 2, okay. I could sort of see the bones of like simultaneous equations. And the last one there, guys. Let's go yellow. That. Yeah. So I'm just writing it all down, right? Just so I can have all the equations in here. M squared n squared equals to 4a plus b. Now, okay, let's have a look. So I've got 1, 2, 3, 4. Yeah. Now the last one has b. So I'm hoping to just use the first 3 to eliminate m and n, and then solve for a. Okay, let's see that, right? So this is what I'm thinking, right? This one here, before I do anything, right? See that there? I can actually complete the square. I'll show you why that's important, right? If I complete the square there, m plus n all squared So I borrow 2 from there, and it's like plus 2mn equals to a minus 4. Check this out, guys. Now, I'm just going to do a little bit of like, targeted substitutions, right? So let's see if I can depict this for you. So I'm going to sub half n plus n into here and here. Yeah, because then once I do that, I can use the bottom one to find mn and then sub that into there, and hopefully I can solve. See, I can find mn, right? I gotta make mn in the subject here and sub it into here, right? And then once I do that, this expression here has both sides. I've used all 3 equations. Both sides have a's, right? And then I should be able to solve for a. So if I call this equation number 1, 2, 3, 4, I'm going to strategically go sub 1 into, let's go into 2 and 3. So I get, sub that into there, I get a quarter. So quarter plus 2mn for now equals to a minus 4. So then 2mn equals to a minus, that's a quarter, so minus 17 on 4. Right, okay. And the other equation I get when I sub that into there, I get mn times a half equals to 2a minus 2. So then mn equals to 4a minus 4. Right, so that's equation number 5 and equation number 6. So the plan now is to sub this into here and then basically make a the subject, right? So I need space for that. I don't have space for that. So I'm just going to copy this line. And in the next slide, I'm just going to remove this bit. You no longer need that. Oop. Probably want to retain that. Okay. Let's see what working. So sub 6 into 5, and I got 2 times 4a minus 4 equals to a. Oh, this is not going to be pretty, right? So I've got 8a minus 8 equals to a minus 17 on 4. I've got 7a equals to, God, guys, I need a calculator. Give me 1 sec. Calculator. So what's that? 8 minus 17 on 4. 15 on 4. Let me just check the mathematics there. Yeah, I think it's right actually. It's just really nasty, right? A equals to 15 on 28. Check that. 15 on 28. Yeah, it looks good actually. Yeah. Yeah, let me go back to my question. I'm finding A and B. Yep, finding A and B. That's A. And then quite simply sub that, right? So sub that into there. And then also replace mn into there. And you got it right. So maybe call that number 7. Sub 7 and sub 6 into number 4. So sub 7 and 6 into 4. Okay. So you got mn squared. So that's like 4 times a, which is 15 on 28 squared minus 4 squared. That's mn squared equals to 4a plus b. Jesus. Okay. Home stretch is just the nastiest of fractions plus b. So b. Now let me punch in. Okay, I'm actually got it. So if you did it right, 64 on 49. Guys, how's that? Yeah. So this question, I don't think it's that hard. I think what turns people off is the fact that you have to solve simultaneously for 4 equations, right? The key to solving this is basically I identified whenever you see like when I see this a lot, right? Whenever you try and solve simultaneous and there's n plus n and mn, don't try to find mn individually. I don't think you need to do that, right? You can actually find expressions for n plus n and mn separately and then replace them to solve simultaneously. That's why they gave you 3 equations to solve for, actually there's 3 letters there. That's why they gave you 3 equations, right? Because you can actually make a connection between n plus n and mn. You can make those as subjects in 2 of them, and you sub it into the third. Guys, hopefully that was nice. Final question, Senior Grammar 2023. If you like that, please subscribe to the channel, tell your friends, and like the video. Thank you very much.